The Snowflake schema begins where the Star schema leaves off. We still have a central fact table surrounded by its dimensions. But here's the twist. Some of those dimension tables don't stop at just one layer. Instead, they branch out into smaller, related tables. These extensions form patterns that resemble the arms of a snowflake. The key idea here is more detail, more structure, and deeper connections. Now, why does this happen? It's because of a process called normalization. Before we dive further into Snowflake, let's pause and understand the concepts of normalization and denormalization, since they explain the key difference between a Star schema and a Snowflake schema. Let's start with something we often see in real life. One big table that tries to hold everything. It has brands, product names, categories, types, and vendors all packed together. At first, it looks fine, but here's the catch. This setup quickly becomes messy. Look closer at the table. Notice how the same information keeps popping up again and again. The brand Dell shows up in 3 rows. HP appears multiple times. The vendor, Smart Supply, is repeated, and even categories like gaming or types like laptop are copied over and over. All this repetition wastes space, slows us down, and opens the door for mistakes. Here's where normalization steps in. Instead of one giant, repetitive table, we split it into smaller, focused ones. And that's exactly why we need normalization, the process of organizing data into smaller related tables so it stays clean, consistent, and reliable. The product table stays at the center, while details like brand, vendor, category, and product type move into their own tables. Each table has an ID, which is just a small number that takes far less space than storing long names over and over. And because computers are great at working with numbers, IDs also make lookups faster and more accurate. But normalization isn't the only approach. Sometimes we go in the opposite direction, called denormalization. Denormalization combines tables to reduce the number of joins, even if that means repeating some data. The goal is faster and simpler queries. It works by merging related tables into fewer, wider ones. The benefit? Reporting becomes easier, but at the cost of more duplication. That's why the Star schema often uses denormalization, keeping dimension tables wide with more details in one place, which makes querying faster and simpler. The Snowflake schema, on the other hand, uses normalization, splitting dimension tables into smaller, connected ones. This reduces redundancy and improves consistency, though it adds a bit more complexity. The result of normalization in a Snowflake schema is a clean and structured model. Every piece of information exists in only one place, linked through relationships with no waste or confusion. This design offers 4 major advantages. It saves storage space, reduces data redundancy, improves data consistency and integrity, and provides flexibility to scale and add new data easily. While the Snowflake schema offers structure and accuracy, it also comes with some drawbacks. It increases the complexity of the data model, making it harder to design and understand. More joins are required during queries, which can slow down performance on large datasets. It demands higher maintenance. A small change in one table may affect many others. And finally, the ETL process becomes more complex, often leading to longer data loading times.